welcome to this edition of Fuel for Thought. I'm your host, Guido Vildoso, Associate Director of Consulting at S&P Global Mobility. In this episode, we're shining a light on the evolving world of software-defined vehicles, or SDVs, an area filled with promise, but often clouded by hype and ambiguity. As OEMs race to position themselves at the forefront of this trend, the need for a clear and objective way to measure SDV capabilities has never been more critical. Joining me today is Manuel Tagliavini, Principal Analyst of SDV and Software at S&P Global Mobility. Manuel is one of the experts behind SDV Readiness Levels, our new benchmarking framework designed to help OEMs, suppliers, and tech partners assess where their products stand in the journey towards truly software-defined vehicles. From foundational technologies like over-the-air updates and EE architecture to unified operating systems and cybersecurity, we'll unpack the 5 levels of SDV readiness and what they mean for the future of vehicle development. Let's get started. Manuel, can you start by explaining what a software-defined vehicle is?
Thank you, Guido, for the introduction and for the first question. Sure, I'm going to start first with a short answer and then I will develop further. A software-defined vehicle is a vehicle which can be updated and upgraded throughout its entire life. But to explain further with a longer answer, I can tell you that a vehicle which is not primarily defined by its hardware, typically now, that is where mechanical components like engines, transmissions, and suspension were the core focus. The software was there, but it mostly supported the specific hardware function and more of an afterthought. In a software-defined vehicle, or SDV, how we can call it, this paradigm shifts. The software is not directly tied to a specific hardware. There is a coupling of hardware and software. The vehicle's key specifications and features are no longer mainly determined by mechanical and hardware aspects, but increasingly by software capabilities. Instead of hardware being the only cornerstone, now there's a balance between 3 pillars: connectivity features, software architecture, and hardware systems. This shift enables vehicles to evolve even after they leave the factory, with new functionalities, updates, and improvement delivered through software updates, much what we are used to with smartphones or computers. In short, in an SDV, what defines its performance, value, and user experience in the cabin, but also in terms of driving features like the fast acceleration, is largely written in software code, not just forged in mechanical parts.
Thank you for that. Let me ask you this. From our perspective, what prompted S&P Global Mobility to develop the SDV Readiness Framework?
This really comes from questions that are coming from customers and that came over the past about 2 years. Everybody is making claims around SDV. It was everywhere at CES, for instance, with all kinds of meanings. OEMs keep making claims around SDV, for instance, here in Europe. In the last couple of months, you had Volvo announcing the ES90 as a true SDV, or BMW presenting the Neue Klasse as its SDV platform. Also, Renault announced the Estafette coming in 2026 as its SDV vehicle. And then Volkswagen also claimed it is ahead of schedule, and the ID.1 will be the first SDV in 2027. Then after all these series of news and OEM presenting this new platform, customers are asking us, are all these vehicles really SDV? What is real and what is just marketing? What is an SDV? Are these vehicles equal? Or what are the gradients of SDV readiness or level? Who is leading? Who is lagging? As we dug deeper, we realized something. There is still no universally accepted definition of what exactly qualifies as a software-defined vehicle. And more importantly, there was no clear way to compare how different OEMs, or even different vehicle models, are progressing towards becoming truly software-defined. In a conversation with key players across the industry, it became clear that there was a real need for a structured tool, something that could help assess and benchmark the SDV maturity of different vehicle and OEMs. We noticed that while a lot of discussion were happening, the industry was missing a consistent reference framework that would break down the readiness of vehicle for SDV, considering the foundation technologies, connectivity, software, and hardware. We didn't just want to describe where companies are today. We also wanted to forecast how they are likely to evolve, providing actionable insight for strategic planning. By creating a readiness score, both an overall score and individual score for each of the three pillars, we are giving the industry an intuitive, easy-to-use tool. This tool helps to identify market opportunities, spot areas that might be underserved, and ultimately drive more informed decisions.
Let's expand a little bit further, Manuel. You mentioned the decoupling of hardware and software. Would you please elaborate on how this concept is fundamental to SDVs?
I can tell you that in the traditional approach, software has been tightly integrated with the specific hardware components, meaning that every time the hardware changed, software had to be rewritten or heavily adapted. With SDV, this is going to change. We are moving toward a model where hardware and software are developed more independently, enabling more flexibility, faster updates, and a longer innovation lifecycle. This is achieved by introducing new software layers, like middleware, that abstract hardware resources and present them in a standardized way to the upper layers, including the application layer. As a result, applications become increasingly hardware agnostic. The benefits are really significant. First of all, software development, testing, validation, and debugging can proceed in parallel with hardware development instead of waiting for final prototypes. This is often called a shift-left approach because it allows multiple software tasks to be moved earlier in the development timeline. Second, it brings much greater flexibility. Once the hardware-software dependency is left tight, software updates, upgrade, and even reuse across multiple vehicle platforms become much easier and faster. And third aspect, it enables a more scalable and modular architecture, allowing OEMs to deliver consistent features across different models and to innovate continuously over the vehicle's lifetime through software updates. In short, the decoupling is what truly unlocks the potential of SDVs, enabling faster development cycles, more consistent user experiences, and continuous improvement even after a vehicle has been sold.
What are the three foundational technologies that enable software-defined vehicles, and why are they critical?
We have defined that there are three foundational technologies that are critical for enabling software-defined vehicles. These are over-the-air or OTA capabilities, software components, and hardware and EE architecture together. Each plays a different, particularly essential role. First, over-the-air capabilities. OTA allows manufacturers to remotely update, patch, and improve the vehicle software long after it has been left the factory. Without strong OTA functionality, vehicles risk becoming outdated quickly. OTA ensure applications running in the vehicle or new application added later to stay up-to-date, secure, bug-free, and it's also a way to create a new revenue stream through feature upgrades and subscriptions. Second aspect, software components. These are the real enablers of SDV. Software defines the services, application, and user experiences. Key technologies here include the deployment of a unified operating system to streamline software development across domains, the use of a service-oriented architecture or SOA to allow flexible feature creation and communication between vehicle systems, and then cybersecurity framework, which are absolute prerequisites to ensure safety and trustworthiness. Third aspect is the hardware, specifically the electrical and electronic architecture. Modern SDV rely on hardware that is designed to support complex software ecosystem. These include implementing zonal architecture, using high-speed communication buses, and standardizing protocols. A flexible and powerful EE architecture simplifies the deployment of software across the vehicle, support dynamic resource allocation, and enables cross-domain functionalities. In short, without the right hardware foundation, true SDV capabilities aren't possible. Optimizing the three foundational elements, so connectivity, hardware, and software, allows manufacturers to reduce development and update costs, minimize downtime, and dramatically enhance the overall user experience. It's a combination of strong OTA, scalable hardware, and smart software design that truly unlocks the potential of software-defined vehicles.
Great insights, Manuel. I- If we put some of these to work, would you please walk us through the different SDV readiness levels that each of the OEMs are looking at and what each level signifies for an OEM?
Sure, the SDV readiness framework is built around 6 levels from 0 to 5. Each level reflects how far a vehicle and its manufacturer, for sure, has progressed in terms of software, hardware, and connectivity integration. But let's walk through one by one to each of them. Level 0. This means disconnected and static. At this level, vehicle operates on a basic signal-based architecture, usually over a traditional CAN bus. There's no connectivity and no ability to receive software updates remotely. Software is static and fragmented, requiring manual intervention for any fix or update. For OEMs, this means high operational cost, low scalability, and increased risk due to the limited cybersecurity measures. Customer satisfaction also takes a hit. Drivers expect digital convenience, and physical updates just don't cut it anymore. Then level 1. This means connected, but with limited OTA or over-the-air capability. This level introduces basic connectivity, allowing OTA updates, but only for static data like navigation maps, for example. While it is a step forward, software is still not modular. OTA is really limited, and cybersecurity only covers basic infotainment. For OEM, the commercial benefit is still minimal. Perhaps a subscription for maps, but the real potential of SDV concept remains untapped here. Then if we move to level 2, for level 2 we mean basic upgrades. Here vehicles can update and debug key functions such as infotainment, ADAS, or even powertrain features. This level marks the entry into service-oriented architecture or SOA. Software becomes more modular and scalable. OEMs can now respond more quickly to market needs, deliver real-time services like predictive maintenance or AI-enhanced driver assistance, and ensure regulatory compliance through remote updates. Then, if we move to level 3, this means efficient upgrades. This level introduces zonal EE architecture, a major architectural shift. Instead of distributing ECU across domains, the control is consolidated into zones. With this, multiple domains can be updated simultaneously through a single OTA session, reducing development cost and manufacturing complexity. For OEM, this level significantly improves scalability and operational efficiency, enables faster time to market for new features. Then we are going to the higher part of the score, let's say. So level 4, this means dynamic upgrade. At level 4, OEM adopts a cross-domain operating system, consolidating software platform across different functions like infotainment, ADAS, and body control. This enables OTA update across 3 or more domains, allows dynamic allocation of computing resources, and supports real-time cybersecurity through cloud integration. By unifying software under one operating system, OEMs simplify development, reduce complexity and cost, and speed up deployment across different vehicle models. While still based on traditional communication backbone, usually CAN bus, the system is now much more flexible and scalable, setting the stage for the transition to full SDV capability. Then we reach level 5. This is what we call full SDV, intelligent and future-proof. This is the pinnacle of SDV capability. Vehicles at level 5 operate on a fully integrated zonal EE architecture, and they implement Ethernet-based networks to manage the high bandwidth need of modern software-defined system, with a unified operating system and real-time dynamic resource allocation across 4 or more domains. From a user perspective, the car becomes a seamless part of their digital ecosystem. It connects with the cloud, with a smartphone, with smart home devices, and learns from the user's behavior to offer personalized and customized services, application, and preferences. From the OEM side, Level 5 enables continuous data collection, which feed AI and machine learning model, improving the in-car experience for the user, but also optimizing the entire factory and supply chain. These levels support predictive maintenance, shorten the development cycles, and improves manufacturing efficiency by using real-world data to make real-time improvements. All obviously within the legal data privacy framework like the European GDPR. Overall, I can say that each level represents a major step forward, not just in vehicle intelligence, but in how the OEMs can operate, innovate, and create value across the entire life cycle of the product.
Manuel, can't help but think, as you walk through the 6 different levels, about the unicorns, the disruptors within the industry. How can traditional OEMs compete with EV startups and newer brands in achieving higher SDV readiness levels?
Thanks for this really good question. I can tell you that traditional OEM initially found themselves lagging behind when it came to achieving high SDV readiness. While new EV startups often had an advantage, they were more nimble. They built their architectures from scratch with software and connectivity in mind, and they could move faster without the burden of legacy systems. However, we are now seeing that many traditional OEM are catching up, especially through strategic partnership and collaboration. A great example here is joint venture between Rivian and Volkswagen. It shows how legacy players can leverage the agility and innovation of startups to accelerate their own SDV capabilities. But at the same time, not all startups succeed. Some of the companies that look very promising, like Nikola and Canoo, they struggle to survive in a tougher financial and market environment. These highlight key strengths of a traditional OEM. Even if they innovate at a slower pace, they generally have the financial resilience and industrial scale to weather market volatility better than most startups. Another important point is the organizational structure. EV startups tend to have flatter, software-centric organizations. Their development teams often integrate software, hardware, and system function right from the start, working in a more agile and cross-functional way. In contrast, traditional OEM have historically operated in a highly siloed organization where mechanical engineering, electrical engineering, and software development are often separated with complex hierarchies and slower decision-making processes. This siloed structure makes it harder for legacy OEMs to move at startup speed, particularly when it comes to the integrated development cycle needed for SDVs. Changing this is a huge internal challenge that many OEMs are now actively addressing through organizational transformation, creating new business units, promoting cross-domain teams, and adopting more agile development methodologies. Additionally, we are seeing new external pressure reshaping the competitive field here, like tariffs, trade restriction, localized supply chain strategies that are introducing new parameters into this equation. For example, market access, production localization, and cost structure resilience are becoming just as important as technology innovation. So, how can traditional OEM truly compete? Here, just a few suggestions. By forging partnership with technology players and startups, maybe also by modernizing their organizational structure to break down silos and accelerate innovation. Also by leveraging their scale and resources to invest heavily in software platform, connectivities, and digital ecosystem. And also by adapting to geopolitical shift to ensure the market access and operational resilience.
Let's shift gears a little bit here, Manuel, and focus on level 4, which introduces a cross-domain operating system. How does this enhance vehicle functionality and consumer experience?
At the SDV Readiness Level 4, what we have defined as Level 4, we introduced the idea of a cross-domain operating system. What does it mean? It is a single unified OS that spans multiple vehicle domains, infotainment, ADAS, body control, and more. This move to a cross-domain operating system, starting from the individual or standalone one, brings several important advantages. First, it reduces the complexity. Instead of managing multiple independent operating systems across different electronic control units, manufacturers can streamline software development and integration efforts. This simplifies the overall system architecture, making it easier and faster to introduce new features and fixes. Second aspect, it allows for much better resource optimization. Using a unified OS, computing power and memory can be dynamically shared across different vehicle functions, avoiding the deficiencies of underutilized hardware. This not only boosts system performances, but also helps reduce overall power consumption. That is a crucial aspect for electrical vehicles, where every kilowatt counts. From a cost and scalability perspective, a cross-domain OS makes it cheaper and faster for OEM to develop and upgrade software across multiple vehicle models, creating a more flexible and future-proof platform. And for consumers, the benefits are very tangible. Vehicle with a cross-domain operating system can deliver more frequent software updates, bring new or improved function and apps over time, and offer a more seamless, consistent user experience across different vehicle features.
Lastly, Manuel, how can OEMs and stakeholders leverage the SDV Readiness framework to strategically plan for the future?
The SDV Readiness framework is designed as a strategic tool for OEM and stakeholders to navigate the transition to software-defined vehicle more efficiently. First of all, this tool allows companies to benchmark themselves against their competitors and the broader market also. By providing a structured readiness score across hardware, software, and connectivity, OEMs can clearly see where they stand and where others might be pulling ahead. Second aspect, it helps to identify competitive strengths and weaknesses. Stakeholders can analyze specific areas where competitors are outperforming them or where they themselves might have an advantage, whether that's in software development, hardware architecture, or connectivity strategies. Third aspect, the framework provides insight at a product level. Companies can assess how many of their own nameplates, their different vehicle models, are also already SDV ready and how many are not. This helps prioritize investment and development resources, ensuring efforts are targeted where they make the biggest impact. And finally, the SDV Readiness framework acts as a sort of a forecasting tool. It allows OEM and supplier to anticipate how the market landscape is likely to evolve over the coming years, helping them to plan product roadmaps, technology strategies, and partnership decisions accordingly. In short, it is not just about understanding where you are today. It's about building a roadmap where you need to go next to stay competitive in the SDV era.
Thank you so much for sharing your insights on software-defined vehicles. As we've learned today, understanding these readiness levels is essential for OEMs to remain competitive and innovative in a rapidly changing market. By prioritizing SDV capabilities, manufacturers can enhance customer loyalty and drive the future of mobility. Thank you as well to everyone for listening in to this month's episode. Please share this podcast link with colleagues and in your social media accounts whenever you can. And don't forget to follow us on LinkedIn at S&P Global Mobility and explore our products and offerings at spglobal.com/mobility. We'll be back for more Fuel for Thought next month. Have a great day.